Just seeing if everything is online. Cool. It looks like I'm live. Um, Although I'm not seeing the restream chat. Okay. Cool. I think I have everything. Um, I'm Jonathan. I'm an artist, tech artist, game developer at Free Lives, and for the past while, I've been working with Robbie, and Evan, Jared, and Jay. Actually, that's quite a lot of people working on it. On a game called Second Earth, which you can check out over here, um, on our itch page. Um, so what I'm going to do today is is to make a shield effect. Um, so the idea is that we have some building that has like a hemisphere, like a radius around it, and that prevents some amount of damage. The shield would protect your buildings or your walls or whatever, and it has some amount of health that um, it takes some damage before it gets destroyed. So I was thinking about what I wanted to look like, and something um, that has always fascinated me, especially when I think about round things, is bubbles and how they have this kind of iridescence, sort of these beautiful hues, but also how with bubbles, as with spheres and reflections in general, um, they they have this edge that you see, and then near the middle, um, it's less, it's like darker or less. There's less going on there, which sort of fits well with like the aesthetic of a shield because um, if the entire thing is busy, like in this one, then you don't really get to see what's under the shield so well. And if these shields are going to be up for a while, you don't really want it to get in the way. So you really just want to see the shield kind of appearing properly when it needs to, like when it takes damage or something. And otherwise, you want it to be fairly out of the way, like just really subtle, so you know it's there, but you kind of don't have to pay attention to it. Um, so I'm going to start out with just a sphere that has had its bottom cut off so that it's a hemisphere, since uh, now that I think about it, this makes it only really work on flat ground. But that's okay. I can change the mesh later on. If at some point we had hills, or if this thing was on the edge of a cliff, then you might see the edge of the shield, and that might look a bit strange. But we can get to that later. So, create a new material for this. Shield bubble. Assign it to this thing. Give it a shader. Shield bubble. Himban says, I couldn't get past the second mission. So difficult. Didn't I see this before? What did you struggle with the second mission? There are a bunch of things to learn. Was it like resources or? Robbie has been working on balancing the game and trying to make it so you can like select difficulty or something, or not. No, there was something about making the game easier though. Oh, okay. Human Bun says the final rush in the second mission destroys everything. Well, hopefully things like shield bubbles could help. Um, cool. So I've not switched across to these newfangled node-based editing tools just yet. Um, um, First, I'm really just stripping out all of the bits that I know I don't need. Because when you create a new shader, Unity does a bunch of things for you. Okay, so this is our bare bones shader that is currently just showing white because there is no texture. So what I have in mind is, I mean, it's also going with the sci-fi trope of like hexagons. I made this thing. It's just a normal map with sort of hexagon tiles. So I guess I'll start with that. Um, Actually, before I get to that, if I play a normal map and there's no lighting, then I'm not interacting with the normals in any way. So there's no way to see if the normal map is working. So to start with, we'll use something called Fresnel, which is just it's basically just a room. So let's do that. So for that, we need world normal, and we need a view direction. I think Unity had a built-in one. World object to world normal. And something like that. And our Fresnel equation is the dot product between the normal and the view direction. And these need to be normalized because I've scaled up my mesh, but also the camera can be far away. And let's just see what that looks like. So, okay, so we have sort of a white on the inside and like this very faint black room. So if we take 1 minus that, then that gives us like this black bit on the inside and then white on the outside. And we can raise this to a power. Using a new variable. And now we've got a number we can use. So that gives us this this outline, but we don't want the inside to be black. We want this basically to be transparent. So we've already said it's the transparent cube, but we need to tell it how to blend and stuff. So we don't want that to right depth, and we want this to blend using standard alpha blending. Okay, and then we need to write to our alpha. So okay, so now we've got this room going on. I need to remember to check the chat. Didn't I see this before? Was in regard to this white bubble thing. Maybe? I don't think we've made it for this game though. Cool. So this is very transparent, and maybe we want it to be less so, and this room might be quite bright. But we can play with the colors later. So now that we have a room, we can start putting in our normals. So let's not, let's see. Okay, let's call it like normal text, normal map. It is a texture, a 2D texture that by default should look like a normal map when nothing's assigned. Declare it here. And maybe we'll just make these two textures share the same UVs. I don't know if we're actually going to use the main one. So let's do this. Okay, so now we look up this normal map. So that's sample a normal texture using our UVs, and make sure that so we unpack the normal, just interpreting it as a normal. And then we have to do some things that I always just copy paste because it's faster. In Unity's manual, they've got vertex fragment shader examples, and they've got this one that says sky reflection per pixel, which is what we are doing. So let's grab this bit. Okay, so we want these. This is the part where using some node-based editor or something would be great, because it'd do this tedious part for me. So this is really just a conversion from tangent space into world space. Um, in retrospect, no, I think this is still fine. So whenever you're doing this dot product, you just really want to make sure, in fact, with any sort of comparison between vectors, you want to make sure that you're working with things that are in the same space. So here I'm using the world space view direction, and I was using the world space normal. Um, but normally in games, when you use a normal map, your normal map is tangent space. So you either need to convert your normal map from tangent space into world space and then do your calculation, or you need to convert everything else into tangent space and then do your calculation in tangent space. So in this case, I'm converting everything to world space. And don't think I need this world normal exposed that way anymore. So I'm not going to be using it. I'm going to be using this one instead. And let's hope that I don't end up with a whole bunch of pink. Oh. Where is this? This. Okay. So I'm not seeing any difference yet, but that's because I'm still using a blank normal map. So if we bring in that hex thing, now we're seeing something happening. Probably want to tile this a bunch. So you can sort of see this happening. So using the normal map to calculate that for now. So you start seeing this pattern going on. But it currently looks kind of rubbish because it's being stretched. So we could just make it so we can see what this looks like more clearly. So now I'm just showing the normal, sort of the tangent space normal itself, and we can see it's being stretched out this way. So if we tile it a little bit more on that axis and maybe a little less on the other one. So the way these UVs have been done was rather naive. And so there's sort of an even stepping, even though out here things are like way further apart, and here they're closer together. But I don't mind that now. I've found working with Blender's UVs to be quite frustrating. Okay, so we're seeing this sort of room that I think is great. Probably don't want the inside to sort of disappear completely. So let's make it so that this gets clamped between some low-ish value and 1, maybe a little more. And really, maybe this should be like a slider or something, but cool. So that's kind of like the opacity of this bubble. Next, we can sort of look at this iridescence. Kimban asks, what is tangent space? Haha. It's a little tricky to explain without showing you something in a 3D model. Oops. Shift Z. So there are a bunch of different spaces that you work in. When you're writing shaders, there's this thing where you're transferring something from your vertex shader to your fragment shader. In Unity, there's this thing called Unity Object to Clip Pos, and that's like sort of a shorthand for taking a bunch of matrices that are like converting between different spaces and really going from so this one's I'm wondering where to start. Okay. Um, when you load in, when you export like an FBX or whatever, and you send it to Unity, the thing that you modeled it in, that is typically called like object space or local space. So there's object space, which is like what you modeled in, and there's a matrix that you can multiply that by to send it into world space, and then from world space you go into like something called, I think it's like camera space or view space, and then the final one that goes to the fragment shader is clip. So this thing, if it were at the origin and it's all like this, then this is local or object space, and then if we took like an instance of this thing and we moved it somewhere and we like scaled it and we rotated it somehow, this could be like then called in world space. And the thing is, you can do this, and that's fine. But if you had like some fine detail in here and you were using a normal map to describe it, if this thing started like deforming, like say it was an arm and it was bending, then you'd kind of need a new map to describe how this looks. Which I wish I had examples for now. Whereas if you use a tangent space normal map, if this thing bends, you can still use the same map to describe it. So I don't really know how much you know about sort of 3D in general, but a normal is... Can I use grease pencil for this? Ha! So you can have a surface, and then the normal is the 90-degree sort of vector that comes out from there, and then you have a tangent, which is a vector that goes tangent to the surface. And the thing is, this could be in any direction around it, right? Because this could be a circle. So we sort of define it so that the normal is 90 degrees, the tangent and the bitangent, or binormal, I don't know what it's called, is defined by the UVs of this object. So if we look at the UVs here, I've got all my arrows around. So I mean, it's just like a standard that you define, but the normal would be coming out. So the normal we can't see here because it's sort of pointing in toward a camera. But then our tangent would be like this direction, like, or this direction, whatever your standard is, pointing in either your V or your U. Yeah, so you, I guess it follows the face or plane. It does. So the normal is very, very strongly about like what direction the face is facing. So whenever you do like lighting calculations or you do this Fresnel thing, as we have here, that depends like entirely on what direction this face is facing, and the normal describes what that direction is. But your tangent and your bitangent, binormal, isn't used in that like lighting calculation, but it's important for knowing what the orientation is of this face. And so our tangent space normal map is a thing that looks like this, say. Let me pull up Photoshop. So it looks like this, where the blue channel, so it's an RGB texture, where the blue channel is like how strongly this vector is pointing like toward the camera. The red channel is like how strongly this vector, this face, is pointing toward like the right. And the green channel is like how strongly it's pointed up or down, depending on what type of encoding you're using. So you can sort of imagine how like if this described which way a normal was facing, as you could like imagine it being projected onto here, but maybe this thing moves around and like the faces are changing because you have an animated character or whatever. That you're always facing, like projecting that map like straight down onto your mesh. So it's like that's like tangent space where you're always doing it straight down into your mesh instead of like, I don't know, world projected or some other type. I need to make this chat window always on top. Appearance. Always on top. Ha. Cool. I hope that was helpful. It's so much easier to draw, but then I have to like switch screens and stuff. It's also easier when you've got all of the examples on hand. I have never actually used grease pencil, and I don't know how to get rid of these things. Do I just select them like this? No. Anyway, it doesn't matter. Cool. So now we've got like the sort of description of this. I think these lines are actually a little fine, because for the most part, when you play the game, you're like more zoomed out. So this looks pretty cool when you're up close like this, but when you're further out, it just becomes a line. So maybe this is because my power is too high, and we can lower that a bit. So now let's look at that iridescence. So we know that there's this sort of like rainbow hue in it. And there's like the physics of why this happens, right? It's like something to do with how this is a very, very thin film. And it's so thin that when light rays enter the medium, there's like some interesting things going on. But I'm not really interested in sort of modeling real physics. I sort of want to, like, we're not using a ray tracer here. This is all running real time. So how can we sort of look at what's real and then sort of take inspiration and see how we can do it in a fast or cheaper way? So something that I've done in the past that is like fairly quick and easy is to use sort of a lookup ramp. So what we do then is we take this Fresnel value and we use that as sort of like the UVs for another texture. Let us make one of those. Okay, I'm actually going to pull Photoshop across, but every time I do this, Windows goes missing. So if I just pull a gradient across, I can color this gradient map in different. Where's this thing? This is what makes. When the stream ends, then I have to move this window back across and then look for everything again. So we can already choose like some sort of rainbow spectrum, and this might be quite bright. I feel like it's also that we sort of want it so that the one side is like the long wavelengths of light, and the other side is made of the short ones. But whatever, it doesn't matter for now. So we just need something like this, which I think is too loud. Shield iridescence. Save. Okay, and now in our shader, let's call it ramp texture. Iridescence ramp. Okay. So now we sample it, but instead of using our UVs, we use this for now. So let's say 3 color is ramp texture. We're using this for null value. And then our result is really this color and the Fresnel in the alpha, I think. Okay, and now this whole thing goes white right now because I said that by default the whole ramp should be white. So if I choose this one now we end up with this. And we can sort of see how it's going through those colors on the edges. It's just, yeah, I mean, we can play with that. There's some things that we just maybe should be aware of. So if we're using a ramp texture, then typically you don't want this thing to wrap. Although in this case it's red on both ends, which I feel like it shouldn't be. So we just need to set that to clamp. And also because it's being used to look something up, it's not a texture that we're like actually displaying. You typically don't need things like filtering and maps. Although, did it change? Can't tell. So it did change, and it seems to look less noisy. Well, if it starts to look blocky and noisy, then let's keep this on. Okay, so we had in our Fresnel, black is the inside of the shield and like white is the very outside. So let's sort of craft this this gradient for that purpose. Need to find my. Okay, so maybe we can just pick some colors. Like maybe it's sort of bluer and green on the inside and tends toward yellow and red on the outside. I don't know if that's how real physics might work. maybe we need more of that red out there. Let us just like put a color over this to sort of try and unify them a bit more. Just generally bluer. But gently. I'm thinking bluer in part because it might be reflecting the sky or something. It's too strong. Don't really like that red. Okay, and maybe the inside of the shield now can be more transparent. Maybe just overall more transparent. Maybe something like that. So now we've got this sort of like static thing. But it would be nice to give this some sort of like ambient animation. Just a very soft or like gentle thing where these maybe these hexagons rotating, or maybe there's like some sort of energy thing emanating downwards. I'm not sure yet, but let's just try something out. Okay, so we need something that'll look like a pulse. Got this weird thing in Photoshop right now where I don't know if I just left it open for too long, but if I want to pan and I drag around, it takes like 2 seconds before it actually starts doing it. Okay, so to do a pulse, let's make some sort of like wave-like appearance. This is frustrating. I think I'm gonna restart Photoshop soon. Let's just save this. Save it as shield wave. Where are these windows? Shield hex. Hey, Hugger. Okay. Yeah, now it's responsive again. Strange. Um, so to make to like draw normal maps, there are loads of different ways. Um, I there's like a Photoshop normal map plugin, but that one doesn't really let you choose the strength from what I remember. Then there's Filter Forge, which I've largely been using. There used to be like the Quixel Endo tools that I used to like using, but they don't really seem to have support anymore, so I don't use that anymore. There's Substance Designer, which is pretty great, but because it's a separate application, it sometimes feels like it takes longer to save something out. So for quick things like this, I just make something fast. FX, shield wave, save. Cool. So now we can put that shield wave in here, and then we need to combine our two normal maps. So now instead of expand, no, there was a thing for like select all. Ooh, don't want that either. Oh well. So this should now be like shield hex, and then we can have a new one that's pulse normal. And we're gonna need a new set of UVs because we're gonna be animating these UVs. So let's do that. Pulse UV and pulse UV is gonna be the meshes UVs times this, but for the pulsing thing. So pulse ticks ST. So we're gonna take our UVs and multiply them by the XY, which is like the tiling part, and add the offset multiplied by time. And we'll use these UVs to look up those normals. And let's just quickly just view those normals instead. Okay, so this is looking really strange. Um, and that is because I didn't set this thing to be a normal map. Cool. So now I can change these offsets. Set this to like 1. You see how it starts like doing this moving down thing as if there was a, I don't know, bubble or energy or something going down. Um, you also see that it's like really noisy along this edge. If I slow this down a lot. Can see this noise. And that is likely because I've left Unity running like for at least a day, but maybe more now. So this time variable, this time.y, that's like how long time has been running since you started the editor, when you're in the editor, or if you're in a game, it's like how long since you started the game up. Which is sort of an interesting thing. If ever you were in QA and you were testing things, um, it's very possible that if you just left the game running for a couple of days, you'd start seeing things looking rather strange. In this case, however, we can maybe wrap this time. Can you get around that by using modular? You can, probably. So I'm using frac, which is similar. It's just taking the fractional part. Snoots McCool. This is Joe. Hope you're doing all right. I'm doing great. Thank you. It's cool to hear from you, man. So frac is not so great because it's now like looping the wrong part. But maybe if I expand frac around this whole thing, that might give me a better loop. When you have this video on your VODs, I believe these videos go into the Free Lives YouTube channel. So they'll be there later probably. Unless for some reason I discover that, oh gosh, somewhere on screen I left like the login details to some really important account, at which point we end up having to remove the video from our library, which may or may not have happened before. So the math for combining normal maps is potentially complicated if you want to do that correctly. If you don't care about doing it like properly, then there are easier ways to do it. And the one that I'm most familiar with is where you do a combination of the red and green channels of or the x and y of the normal, and then with the z you just normalize the result. So that is really just something like this. And this way we've got like that hex tiling thing, but we also have this rippling bit going on. So that's too fast. But maybe if we tile it or something, I don't know. Can probably make a better texture for this too. let us do that. So, how should we do this? We could use one of these distort filters, give it one of these. What do they do? Hearing sirens in the background. Okay, something like that. Just need to make sure that it loops okay, which it does not. Okay, that's all right. We'll just have to paint it out. I'm gonna do this on the other monitor because then I have a tablet and everything becomes so much easier. If you will just bear with me for a little while. Soft brush. Sort of getting there. There's a forge filter that is really just the blur. It's an ordinary blur, but just tell it to tile seamlessly, which is handy. And then make this a normal map. Save this up. Oops. Save. Okay. And I'm not really seeing any difference, but it's because this thing's being stretched across the whole shield. So if we just tile it more along that, then we end up with like more of a ripple, I guess. Maybe that's a bit strong. Tile it more. Is it possible to adjust the strength in the shader? Is it easier to adjust in texture than to adjust in the shader? You absolutely can adjust it in the shader. Um, it just seemed faster for me to 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 drag the slider in here. In fact, doing it this way is like the wrong way. Because if you do it this way, you actually need to like normalize the thing afterwards. I'm just being really lazy about it because uh, I'm fiddling. Um, so I think something I want to do is this. So we do have this like ripple going down, but it feels like the ripple and this hex tile thing are like different things. So it's like it's really obvious that one is just going over the other. And it would be really cool if this like rippling thing, if that like made the hex tile itself ripple instead. So let's do that. Okay, I'm gonna leave this here in case I don't like this. And instead of blending these, I'm gonna use the 1 to offset how we look this up. So okay. I don't know if you can see, but the hex thing does have this distortion going down. It's just because it's only ever that line, it's not very obvious. So let's give it something more obvious. I think I have a bunch of noise textures in the project already. So it's sort of shimmering like looking through water, but that's not quite what I want because I actually want that directional feel. Maybe if we tiled it a bunch along the one axis and not much on the other, maybe the noise stretches and it looks more interesting. So I was saying before that I felt like maybe this line between the hexes is too thin. Let's actually just see how close the camera gets in the game. Oh, I should hide these debug views. Okay. Can the shader create a wavy line normal map from a regular straight line gradient? Yes. So there's a lot that you can do with like just using maths and like sine waves and whatever to manipulate things. But you sort of want to think about like maybe think about how much you want to put into each thing. So why I say that is like if you have the waviness as part of a texture, then you have the advantage of like the shader's reading this texture either way. So if you put the waviness in here, then it's just reading up the texture and it doesn't have to do anything else. And that's potentially a good thing if like your pixel shader is getting like quite expensive, to have like that work done in here instead. But obviously then you lose out in some other way because now this is like waviness that is been baked into the texture. And then if you wanted like more of a procedural waviness, then you don't get that. So if you do it using like your maths and you're doing it in the shader, you tend to have things that are more interactive. But then the downside is like it's more expensive, and especially when it comes to things like trig functions, those can potentially be bad. So this is as close as we zoom in, which is like quite a bit, and then more typical game view is like not that close. I think this is pretty cool. Is that a tree growing? Yeah, go trees. So if we had multiple ones of these that were like stacked around, I feel like it might be a little bit on the loud side. So maybe turn this down a little more. Say opacity. And now we have a slider. Bun says, I almost never zoomed in. Yeah. Yep. So it's like it's most important that things look good at like the view you're most likely playing these at, which is zoomed out. But we also want it to feel sort of cinematic, where you can go in and see people up close. Bubbles. Hmm. Um. So, so right now I'm thinking that I guess there are two things that I can add to this that I think will make it better. The one is I feel like where the bubble like intersects things, there should be some kind of like, I don't know, something like a, a line, like it's brighter there. Um, that would be good. And another thing is, I don't know if I feel like this might not be an issue. I feel like this is quite uniform, especially when I look at it from a bit above. So like this, I like where it's this like half circle, and I think I'd like to keep more of that so that the side that's like closer to me is softer, like in general. But that one, I don't know. That's something I would experiment with, and I don't know if it would work out. So we can do that intersection thing. I also think that we could probably use a better noise texture. This one is very, very noisy. Okay, let's do that first. So I want a tiling noise, and we want it to not be so noisy. And probably even having a bit of direction in it might be nice. So like just by stretching it, I guess. Cool. And let's make this higher contrast. Maybe not. Okay, let's not. What I usually do is I just make things higher contrast anyway. Um, because it's easy to take data out, but it's hard to put it in. So like um if I have something that's low contrast and I multiply it by like some large number to make it higher contrast, then I end up with a lot of like banding and stuff, which is kind of what you'll see here. If I look at levels now, after I did that levels thing, I've got like all these bands. So I just want to blur it once more with that like tiled blur, just to smooth that out. And now if we look at it, it's a lot smoother. And if we ever didn't want this to be like to have as much contrast, we just it's easy to multiply by a small number to take contrast out. Cool. And make it a normal map. Something like that. This still has that noise. Let's blur this again. At this point, it might have been smarter to use Substance Designer or something, because its tools are just more specialized for this. Cool. Johnny Man says hi. Hey, Johnny Man. Cool. So to do this thing where you do like lines where things intersect, that is typically done by looking up your camera's depth texture, which I think we would have. Okay. I'm just gonna pull up another shader that might have used it so that I particle levels. So I can just copy that across. I've struggled before with looking up the camera's depth texture because of how there have been multiple ways to do this, and one of them doesn't work, but at the time it was still all over Unity's documentation. So now I just copy what I know does work. It's gonna be pink. It's not. I'm sorry for doubting. Okay, so this thing is giving me, it looks like the opposite of what I want. So as with before with Fresnel, okay. So now, where this gets close to an object, it like goes white. But that distance currently looks quite thick. Mm. So does lowering, I see. We just raise it to a higher power. Raise it to a higher power. We get a tighter line. Cool. So now you can see how that edge highlights, but it's only highlighting on the side. We're not seeing it on the other one. So maybe we need to make this mesh draw double-sided. I'm not a fan of that. Okay, well, let's just see how it looks before I most likely change my mind. So we say call off, then it draws both sides. Um, so I'm looking for sometimes what happens is because this shield doesn't draw to depth, um, it has no way of knowing if like one triangle should be over another one. So the order is like just the order that the triangles are fed to the GPU, like the order that they were built in Blender. But I'm not really seeing that sort of ordering problem, so maybe it'll be fine. Um, what is a problem though is that this the things that are the triangles that are pointing away from us are looking very red. Um, what do we do about that? Um, so I can find which faces are facing away from us and manipulate their ramp somehow. Or I could flip this ramp. flipping the around makes the red on the inside and the blue on the outside, but it also makes that part blue. Um, I think so. I think if I duplicate this mesh and I make the copy have its normals pointing inwards and color the copy's vertices and then merge the two, then I can use the vertex color as like my how I choose whether something's inside, like facing in or out, maybe. And that way, maybe I can use the vertex color as, I don't know, an opacity type thing or something instead. Um, let us try. Okay, we'll make this copy ever so slightly smaller. Um, how do you flip normals? It's not something I've had to do in Blender before. Blender, flip normals. Control Shift N. Although this is old Blender, so who knows? Okay. Blender 2.8. Flip normals. I'm looking up Blender's vertex colors now. How do I edit vertex colors? Hmm. Um, I guess I'll go search for this or for the stream because then I don't feel like someone's watching me search. Um, I think one last thing that I wanted to do on this, so I'm gonna set this back to the previous one where it was flipped. I'm gonna give it like a cracked state for if the shield's damaged. Mm, oh gosh, doing that thing where it lags behind again. Hmm. Okay, shield cracks. Oh, we should probably give the intersect color. And here. Okay, so now we can choose to make that intersecting color a different hue. And maybe it should be able to be really bright optionally. I don't know. may change my mind later. Okay, cracks. Maybe we can use this for now. And we need another set of UVs. Um, so when I made this mesh, I made two sets of UVs. The one was sort of where it was unwrapped like a cylinder. The other one was like flat projected from the top. So now I'm using the flat projected one. Um, I don't know what order this should be in. Should the pulse affect the cracks? Let's say yes. Pulse strength. Maybe this was what was making things feel so noisy. It was actually just too strong. I think these cracks need to be more opaque somehow. Like there's color, like it affects the color, not just the normal map. And I'm not really using this as a normal map in the first place. So maybe I can change that then. Um, so I'm just gonna use this for the like darkening information. And then this for the offsetting. And then I can pack the darkening into here. So it sort of looks a bit like a normal map, but you can kind of see how it's not really the same if you look carefully there. Then so then for shield cracks, then this should not be used as a normal map. So instead of unpack normal, say cracks dot rg for the red and green channels equals okay, so now this should still function the same way as before. Or so I thought. Um, I'm keen to take a break. So I think I'll call the stream here. But yeah, when I'm done with this, like later this evening, I'll probably put a GIF in the Discord, in the Free Live Discord, or on Twitter, so you can see what it ended up as then. Uh, thanks for joining me and hanging out. Have a good evening. Doop, 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 doop.